All right, we're on chapter 8, moving right along. So we can't have too much work for the rest of the year, being that we got 8, we got 9 to do, and 10, and then 11 and 12 is the same chapter, basically. So we basically got 4 units left. And we got 8 weeks to do it, and that's about right. All right, what we are going to work on is we're going to work on similar polygons. So this is chapter 8.1, similar, and we're going to have to learn what similar is. Okay, similar polygons. And just looking at here, well, we don't have a lot of definitions. In fact, we have no definitions. We are going to have some theorems. And so what we're going to start with is understanding what similar means. And so we're going to write the definition of that. Basically, what similar means is it is the same shape, but different size. Same shape, but different size. So we're going to learn a little bit about that. We are going to work on corresponding parts of similar polygons. Okay, we did this with congruent polygons, and I'm going to actually explain what congruent actually is. This congruency symbol, well, this top part of the congruency symbol means similar. This part, of course, means equal. So what congruency actually means is similar and equal. Okay, so looking at similar shapes, and I'll draw a couple triangles here. And we use similar shapes all the time when we build things, because you draw a small picture and then you a lot of times build a big building from a small picture. And so similarity is what they use. So let's pretend that these are similar triangles. Same shape, different size. So I'm going to call this A, B, C, X, Y, Z. So in this case, angle A is congruent to angle X. And I mean congruent. Angle B is congruent to angle Y. Angle C is congruent to angle Z. Okay. So that's the same thing as when they are congruent, as all the angles are congruent. Here's where the difference is. AB over XY equals BC over YZ equals AC over XY. XZ, I mean. Okay. What this statement means that triangle ABC is similar to triangle XYZ. And I probably need to go over what this means. This is a ratio, right? A ratio is where you're comparing two numbers. In this case, it would be the distance between AB over the distance to XY. So the ratio between the small shape and the big shape, each side is going to be the same. So we're going to look at an example of this real quick, just so you can kind of see how that works. So make a little small triangle. I'm going to make a big giant triangle. 5. Okay, so I have these two shapes that you don't see, and it's very exciting that you don't see it. Now you see them. Okay, and I'm just going to put the same letters just so you can use the same formula. And so let's determine if these are similar. Okay, and so the angles, I'm going to just say the angles are all congruent, just like up here. Let's compare these ratios. So 5 would go with what? 50. What would 6 go with?
16,
What would 4 go with?
20.
All right. So how do we know if they're all equal? Can we reduce them all to the same number? What would be the fraction here? 1 over 10. Are they 6 over 60? Is that also 1 over 10? So they all equal the same thing. This right here is called the scale factor. You remember that term from a long time ago? Basically what this is saying is that this triangle is 10 times bigger than this triangle. So like 1 inch on this triangle would equal 10 inches on this triangle. You've seen that before, yes? Okay, these would be similar. If, for example, one of my sides, instead of being this, what if one of my sides was this? 10 over 20. Would that be the same scale factor? So that would mean that something's different about the shape. They're not similar. Okay? So that's basically what that means. So let's go ahead and look at, and then we'll kind of go over some problems. Let's look at the two theorems. Theorem 8.1 and 8.2. Go ahead and write those down. They're on page 378, 379. And then we're going to look at them and what that's going to do for us. And this is going to be one of the few chapters that we're going to deal with exponents. Super exciting. Well, that's true. Everybody does love exponents, but it's not very hard, so I wouldn't worry about it too much. All right, the first one, perimeter of similar polygon. Basically, the perimeter has the same scale factor as the sides. Okay, which kind of makes sense, right? Because if all the sides are in scale with each other, just adding up all the sides, what would change? Nothing would change. It's like stretching out your triangle. Theorem 8.2, this one's a little bit different. And so we're going to kind of look at this one. And so I got these two shapes, they're not great. And so we're going to look at 8.2, or I'm actually going to look at both of the theorems here with this. So I'm going to call this 10, this 10, this is going to be 8, this is going to be 8, this is going to be 5, 5, 4, 4. Okay. So when we're comparing sides here, definitely we got 8 over 4 and 5 over 10 over 5, right? Are those going to be congruent? Are they going to be the same scale factor?
Oh, yeah.
So that'd be 2 over 1, right? So let's look at the perimeter. 10, 10, that's 20. 36 over 10, 18. Is that going to be the same scale factor? Okay, because basically you're just stretching these out into one long line. All right, what's the area of this one? 80 is the area. What's the area of this one? 20. Okay, definitely if I do the area over the area, it's not going to be the same scale factor of 2 over 1. And so what it wants you to do is take this 2 over 1 and square it. Do you know how to do that? I'll just give you a real quick refresher. Basically, when you have a parentheses like this, that means to do 2 squared and 1 squared. So this is going to equal 4 over 1. So let's see if 4 over 1 equals 80 over 20. Does it? So that's basically what that is. And just to know that, when you do area, you're measuring in squares. Okay? And so if you have a 2 by 2 square, your area is going to be 4. Okay? If you have a 4 by 4 square, 1, 2, 3, 4. Okay? So the perimeter, and you can check me on this, the perimeter of this square should be 2 times bigger than this one. So the perimeter of this one is 2, 4, 6, 8. Let's see what this one is. 4, 8, 12, 16. Is the perimeter twice as big? Okay, but the area should be not twice as big. The area should be 4 times bigger, right? And it does look like I can fit 4 of these squares into this other square. That's how area works, right? Just to help you understand that. So this is basically what we're doing this first assignment. So I'm going to help you with your work. So turn to page 381, and I'm going to show you kind of what to do on these problems. And it doesn't start out super duper hard, and we're probably going to do more than just this today. I don't know if we can make it hard even. We'll see. We'll see if we can make it hard. We don't want to, though. In exercise 3 and 4, you're going to have to do 4. Find the scale factor, then list all the pairs of congruent angles and write all the ratios of the corresponding side lengths in the statement of proportionality. Okay. Wow. So basically what it wants you to do is this. Well, it gives you the similarity statement, right? So I'm going to do 3. It's similar to... Okay, that means all the angles are equal. That means angle A is going to be congruent to which angle? L, right? Angle B is congruent to what? M. And angle C is congruent to N. By that I mean that letter, N. Okay, that's easy. We did that before when we did congruent triangles, right? So let's do the proportion. 4.5. Well, it's going to go with what? Let's see what it... Oh, it actually doesn't want you to do the work. Okay, it actually doesn't want you to do that. It wants you just to do this part. I was making you do too much. It just wants you to do AB is LM. BC, what would BC go with? And then it wants you to do AC. That's all it wants you to do. You're going to do one on your own. All right, let's move on to 5. Let's see if 5 is a little more challenging. The polygons are similar, find the value of x. Okay, this is why I'm doing this. These polygons are similar, find the value of x. Okay, this is how I set that up. I'll just pick a side. 21 goes with what number? 14? And that's going to equal x over what number? 20. Does everybody see where we got that from? Because JL goes with PQ and JK goes with PR. So what do I do from here to find x? Or can we cross multiply? Do you remember doing that? There are other ways to do it. We could find the scale factor. And actually what a lot of people do, instead of cross multiplying here, if I find the scale factor and simplify this and turn this into 3 over 2, is that going to make my math a little easier? You can do that. I do that. Some people don't like to do that extra step. I do that so I can do the whole thing in my head. Is that right? Does it make sense? And this is what I mean by it making sense. On PQR, is 20 the longest side? So then on JLK, X should be the longest side. So if X equals 30, does that just make sense? Yeah. Okay. So any questions on what we did here? Do we remember cross multiplication? Okay. I didn't have us do a lot of practice on that. Okay, moving on to 9. We don't do those, actually. So then we're going to move on to 11. Find the ratio of the perimeters.
Wait, where'd you get 2x over 2?
Right here. So 2 times x is 2x, and then I divided both sides by 2 to solve.
2x.
So when I cross multiplied, I got 2x equals 60. And then the next step is divide both sides by 2 to get the answer.
You don't put it into a fraction?
No, when you cross multiply, it kills the fraction.
Oh, okay.
That's the purpose of cross multiplication. Yeah, and we might have slept since then. So we're going to practice some of this a little bit later, but I just wanted to get into it.
So then why do you divide by 2?
To solve for x.
Oh, right, okay.
Yeah.
A little bit tired today.
We all had a spring break. Mine was absolutely fantastic and wonderful, and it was really, really hard for me to focus on actually doing work today. You know, I had to remember, where was I? And I'm like, I guess I'm the one that's in charge, and so I probably should know. And so I figured it out, where we're supposed to be. We started on the correct chapter. It's good. That's why we take a test the Friday before spring break, so we don't have to remember what we just did. We just can start brand new, right? Imagine having to take a test today.
Oh my God.
And some people actually have to take a test, but not today.
Yeah.
They need to take it tomorrow. Because today is today. That's all we can handle today. All right. Where were we?
11.
Find the ratio of the perimeters. Well, but how can I find the perimeter? They only give me like one number.
Well, it's a rectangle,
It is a rectangle, but they didn't give me enough numbers.
so then you just put the x.
I don't even need the x. I can do it easier. Let's find the ratio between the two sides. What do we think 12 goes with? Well, let's simplify that down to get my scale factor. What would that be simplified? 3 over 2? Well, guess what my ratio between the two perimeters is? Because the theorem states that the ratio of the perimeter is the same as the ratio of a side, right? Well, that one wasn't too bad. Okay, let's look at 13. 2 polygons are similar, the perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. Okay, this should be easy. So here's 13. They gave us 48 is the perimeter of one polygon. The other polygon would be x. And I'm supposed to do the smaller polygon as 48? Let's see. Does this make sense? The smaller would go with the smaller number, yes? And the missing perimeter would go with the bigger number. What do I do to find it? Just cross multiply, right? Fortunately, this particular lesson isn't it's definitely not the hardest place to start. Okay, and if I did this right, this number has to be bigger than this one, right? Because this is the bigger polygon. So always check, because this is real, and so always check the logic and see if it works. Does that make sense? Do what? Yeah, because it said the smaller polygon is 48, so the bigger polygon has to be bigger than 48. Does 72 make sense? Okay, that's all you do on that. Moving on, let's look at 19. 19 is a little bit harder, sort of. 19 is going to use that second theorem. It's going to deal with area. Okay, and so this is what we got to do on 19. We got a couple rectangles hanging out, minding their own business. And this one's 6 feet. This one's 3 feet. And the area of this one is 27. And I want to know feet squared, right? Area is in feet squared. Anytime you do area, you use squares. So this one is going to be, what's this area going to be? I guess I could make that my x. Well, first of all, let's line this up. 3, 6. Simplify that down. 1/2. This would be the scale factor, but I don't want the scale factor. Scale factor is great for line lengths. It is great for perimeter, but it's terrible for area. So basically what I want to do is change this into the area factor, which is my term, not the real term. So this is how I turn it into an area. I have to translate it. Areas are always in squares, not in lines, so I need to square it. And so this is going to equal 1 squared is 1, 2 squared is. So I like to call this the area factor. And we're going to use this even in the last chapter. And so I can use the area factor to find the area. So let's see. I know the smaller one. The smaller one is 27. I don't know the bigger one. The smaller one is going to go with the smaller number. The bigger one is going to go with the bigger number. And then I cross multiply. This is the hard part. You see how I converted the factor into area factor, basically? Even though that's not the real term, that's my term. In the last chapter, we're going to have another thing, and I'm going to call it volume factor, which is even further beyond area. All right, cross multiply. Bam, bam. 4 times 27, 1 times x. This is a one-stepper. 4 times 27, 108. So basically, the area of this is 4 times bigger than the area of this. The line length of this is only 2 times bigger. Okay? So that's it. Yeah.
After you get the area factor, can't you just multiply the denominator by the first area?
In this case, you can, because this is such an easy fraction, and you have a 1. But what if you had a scale factor of 2/3? If you had a scale factor of 2/3, the area factor would be 4/9, and then you'd actually have to cross multiply. So I'm showing you how to do it if it gets harder, but in this case, you're right. It's shorter. So good question.